we are going to continue the data file and the indexing structure. So for the right now you supposed it's a phase 4, right? So due date is November 8th, the next week. So please continue to work. It's basically to create your database based on the setup of the MySQL database. So you can use either the AWS or GCP. But Divya, she is preparing the AWS, the application using the AWS Beanstalk, Elastic Beanstalk, which is the same service as the so many different names of service. So in GCP, it's called the App Engine. Okay, so it's the same service as the App Engine on AWS, but it's not done yet. So if you are interested in the AWS, basically the bottom line, their basic architecture are the same, so you can research and use AWS also. But anyway, during the phase 4, so you need to create your database on MySQL database based on your design and the setup of your database system. So from the last class, we are talking about the kind of from the 3 schema architecture. So we mostly discuss about this conceptual, the view of the database, like how to design the database and how to organize and do the ER model. Then we have the relational database model, including the external view. External view can be implemented by the view object, so they're using SQL. So from now on, the second half of the semester, we cannot cover everything of such an internal internal structure, but definitely you better know how the DBMS system is organized, and we cannot cover each and every component, but based on our discussion last class, so we are going to talk about the data file and the index file and the other query processing, query optimization, transaction management, backup and recovery as much as possible if time allows. Okay. So today, the last class, we have seen how to store the data, which means when you create the table, the first should be interpreted. It's compiled, right? So actually, it's much easier the compiler. If you implement the SQL compilers, actually interpreter, the SQL interpreter, which is much easier than the general program language. Okay, general program language like the Java and the Python, they have bunch of, even it's a cookbook for each program language is several hundred pages or sometimes 1,000 pages. But the SQL itself is much simpler than. That doesn't mean the SQL is just the short, very simple, but it's much easier than the interpreter or the compiler. But still, so it's interesting to implement such a SQL interpreter based on the standard. We should follow the standard. So we have such a SQL interpreter, SQL compiler, through that the query processing, it can be optimized. Then finally, so we the DBMS create the table somewhere on your system. It's a storage. Okay, at that time, how to create the table is the main topic of this one. Okay, there are 2 main approaches. One is using file system. So you are going to use the data structure provided by the operating system. Okay, so you can use the file. There are different types of file that we discussed: unordered file, and the ordered file, and the hash file. So ordered file, you are going to sort the data by what? The key. In terms of relational database, it will be primary key. So on the other hand, the unordered file is just append at the end of the file. So like the heap or the pile is the such an unordered file. The benefit of the unordered file, you can just append and append and append. You don't have to sort. On the other hand, the ordered file, you need to manage the order of the data, so that will be overhead. So unordered file is more common. And hash use the hash function, so it can be classified or into one of the hash bucket depending on your hash function. So idea of the hash file is you can narrow down the search area. So if you are using modulo 10 as we talked about the last time, so your search area roughly reduced to the 10% of your data. It's huge, the improvement in terms of performance, right? So by applying only the simple function, even the modular, most of the hash function are simple. Then you can speed up 10 times faster, right? So that is a hash file. So when you access the unordered file, definitely the complexity is n/2. N is what?
Number of entries.
Number of entry, but think about we are using what? When you talk about the file system, each file actually has a number of blocks. Block is what? I/O unit. So when you read one byte of one record, one entry, but entire block will be returned. So when you calculate the complexity of the database, or actually the many other things, so it's not actually entry, it's a number of blocks. Okay? So key, especially in our database system, we will use number of blocks for the n. What about the order? We are able to use, when you search data, binary search, right? What is a binary search? What? So complexity is log, and is on 2, and the how it works. Cut in a half, right? It's a binary. And if data is bigger than half, going to that half, half, and half. Because of that characteristic, is log n, the base on 2. Okay? It's a binary. Do you think binary search, the log n, is fast or it's not fast? Very fast, faster than the linear, right? It's like the logarithm is like that, the linear is like that. However, it's still monotonic increase. The more data you have, the longer time. So log n actually is not enough for our search. Okay? That is faster than the linear, but still not good enough. So we need to address that. We will see today after we finish this one. Then this is really the very basic approach how to create such an internal. It's an internal data structure, internal view. So DBMS has different. Each DBMS has different data structure. So first time, and easiest way is you can create the unordered file. You can use a heap data structure to create the table. So which means you can create the one file under the directory. So directory will be table space like that that we discussed. In terms of MySQL, you create the database. Then the use database. Then finally you can create your schema, table, index, view, whatever, within that the database schema. So similar, the method is the easiest way to create the internal data structure of your DBMS system. Okay? First time we have used, still many of DBMS educational purpose, or even nowadays NoSQL database use such an approach. Okay? Anyone who took the big data? So, or the Hadoop. Hadoop is a big data solution. So Hadoop actually has the file system, distributed file system that very similar as this one. Okay? So it used to actually store the big data as a file, but distributed. But really big, the block size, 128 megabyte. Usually we have the less than 1 megabyte, 512 byte, or the even DBMS nowadays 2K, 4K, not bigger than 2 megabyte as the database block size. But this one, big data, has 128 megabyte, sometimes 256 megabyte, because it's big. So that is the one of the approach. Another approach is because anyway, we need to use the file system. It's one more step. You need to call the library. So when you are using the NTFS or FAT, the 1632, EXT, UFS, MFS, you are going to call the API or the function or method operation provided by the file system. So it takes a little bit more time, longer time. It's a latency. So it's an overhead. So why not bypassing such the file system directly? The DBMS create the internal structure to the hardware. It's called the raw device approach. The raw device approach is creating the table, first the table space under the DEV, the HDA, the 1. This is the kind of table space. Then mostly they are using what? System library to write the data using what? Offset. So you need to know, manage all. It's just byte by byte by byte. Actually, it's a block. It's a low-level block, like the logical block address created on your hard disk drive. So you can directly, means the DBMS, directly manage such a thing. Because of this reason, somebody said, so DBMS is not just the normal general purpose application, it's a kind of in-between operating system and application. It's directly derived. It's a kind of the new file system. It's its own file system, okay? And also, DBMS later check the monitor, directly access a lot of memory. It's a buffer management. That's one of the job of the operating system. And also in monitor, create the process even. It's another the important part of operating system. So one time, it's a long time ago, maybe 10, 15 years ago, the Oracle tried to create the DBMS operating system, which means, so first when you install any application program, including DBMS, Oracle, Informix, DB2, whatever, you need to install operating system. You should have the Windows or the Ubuntu or the something macOS, any operating system. Then on top of that, you can insert the DBMS. But Oracle realized most of the database user, Oracle user, they install only Oracle system. Then they are not using a lot of operating system, function, or the service. Why not combine? So Oracle tried to integrate, combine the operating system and database. What are the results? It didn't work. Okay, they should take care of all operating system that dedicate to the specific CPU and device and everything. Is too much overhead. So people don't want to use such an operating system based DBMS. So right now, even I forgot the name of that project. But that makes sense. So you will see the operating system. So many of the functionality used in the DBMS is same as the overlap with the operating system. So this is the way how to create the table using either file system and the raw device. We are going to quickly go over this and keep in mind this is the hardware level. The data structure is called the sector, and eventually the logical block will be allocated. Nowadays we are using more and more SSD, the solid state disk. What is the main difference between the SSD and hard disk drive?
SSD is way faster.
faster, much faster. Okay? And which part? Yes, no moving part. That's very important. This one, you can see that this one is the disc. Disc is rotate based on the spindle. Okay, then there is a disc arm. So tip of the disc arm, there is a header. So you can read the data through the header. So how? So disc is moving, and have you ever used the LP record to listen to music? LP? Anyone? No? You never seen the LP? It's a really long time. Are you 40? So it's a long time. LP is rotating, and there's the needle, then the reed, it's like the I don't know exactly how, but anyway, there is the whatever. So they read expand the sound and like that. It's exactly the same mechanism. So head is moving forward and backward, and disc is moving. There's a little tiny gap between the surface of the disc and the tip of the head. Then there's a kind of the line. So if the hole is the 1, if the close is the 0, like that. 0 or 1 will be represented by the hole 1. It's a close and open. Then the CD is the same mechanism, and DVD is the same mechanism. Difference is the density. Okay? But problem is, if this one is, let's say this is a header, touch the surface, what happened? It's a scratch. So scratch is the most problem of the hard disk drive. That is the reason if you are using the hard disk drive, if you drop, so it's the damage. Most of the damage is from the scratch. But SSD is based on what? Memory. Actually, it's based on the memory. So it's a much simpler structure. So as you know, memory is how can you define what is a memory in one sentence?
Application that can save data.
Yes.
Storage.
Storage. Using what? Set of address. It's just a set of address. Their mechanism is very simple. Eventually, they store the 0 or 1. Let's think about, so if you search the Google, what is the first the version of the memory? The memory is, do you know what is the name of that toy? If you rotate like the gear, there's the sound like that. Or there's such a toy. Yeah, I forgot the name of that. So, carbon. I forgot the name. But anyway, so that actually there is something make the sound for each the C, D, E, F like that, then rotate. So memory, first version of the memory is a drum. Okay, you can one line there's 8 the line. Then that represents 8 bit, 1 byte. So if 0 is nothing and 1, there is the pin, and 0, nothing, 1 pin. So you can recognize 0, 1 and 0, 1, 0, 1. Then they send the data. Then the rotate. It's a drum, memory drum. So similarly, any memory represents such the 0 or 1. It's an array of such a 0 or 1. Then problem is how to organize it. It's based on byte and 4 byte, and because of that, it's a little endian. So if you represent such a byte data from the beginning, the most significant bit first, or least significant bit first, either of them. But all of this will be represented by what? Address. So it's a set of address. So if you can represent a set of address, so you can use such a set of address, use such the address as a storage. It's very simple. So it's a much simpler. What is the problem? Then why still we are using hard disk drive? The cost. Right now is the 1 gig is less than the dollar. So it's much cheaper. But hard disk drive still, so in terms of course, is better. Okay? Also, hard disk drive is getting faster and it's reliable. So still, I don't think the hard disk drive will be gone quickly. Most of the device that need save the space, okay, you can use SSD. But because of other latency, sometimes the bottleneck is not hard disk drive, it's the disk controller and network. So some of the system still use the hard disk drive. So that is a hard disk drive. So you can actually when you purchase the hard disk drive first time, so it has the logical block address from outside inside or inside outside. It's outside to inside, write the data, 0, 1, 2, 3, 4, the address. So it's a block. The main point is a block by block. Okay. Then this one is the data structure, database structure. Record means tuple. So how can we represent the tuple? With the data type. So there are two different types of data type fixed or the variable length of the record. We already talked about that. Blocking is block is the really basic unit. So we have the hardware level block, logical block, and the operating system level block, OS block size, mostly 512 block. This one blocking means the database block. Okay, by combining number of the OS block. Okay. So most of the system, you can set up the different size of the such a block when you create the database. At that time, there is another important blocking factor. So this one is a 512 byte block, database block. We are going to use the database block size 512 byte. And record size is 100 byte. So how many the record can you keep? It's a 5. Okay? So this number 5 is called the blocking factor. How many on average? How many records per block? Okay? How many? So how can you calculate this? Block size divided by the record size. Then can we keep the one record for the remainder? You cannot. So you can use blocking factor. So it's a float function. Okay. Then why this is important? Blocking that determine the performance. There are other factors when you consider the performance, like the CPU speed and the bus the speed and the memory access. But comparing to your storage access, they are almost you can ignore. Okay, this is dominant factor of when you judge the performance. Okay, so that is the blocking. We will see a lot the blocking and the blocking factor and so on. And the file record. So there are operations when you create a file. So now these operations are very similar as the file on file system. But we can find some new and unique, like the reorganize and the read order and so on. That is for the database management system. Unordered file and the ordered file. So the slide shows how blocking factor blocking is used to create a table. Let's say this is one file. It's an employee table. Okay? Employee table has a number of records like that. Each record has a number of column attribute. So then it's a name, SSN, the birth date like that. You can see the block number. So block 1 has such a 1, 2, 3, 4. We don't know how many, but the number of record. And block 2 is block 3. So for example, if I search the data, the Troy, for example here, when you read the data, the DBMS find the block number 4, okay? Then copy this block to the memory. Then read the data the electroid element. Then return to the user. Still keep this block on the memory. Okay? Then maybe next time somebody use or other SQL read the case ender, you don't have to go to the hard disk drive again. Instead, read the data from the memory. So that is called the hit ratio. Hit ratio means number of memory access. So number of block, definitely, and number of the total block access. What is the percentile? And what is the percentile to read the data, to read the block from the memory? Question. But in general, what is the percentile? What is the hit ratio of the database management system? Anyone guess? 100%? Does it make sense? If you turn on, where are the data? It's on the hard disk drive, storage, not in the memory. Definitely you should read the data from the memory, either hard disk drive, storage. So 100% is ideal, but it cannot be possible. Yes, just guess. 70? So much higher. 80? 90? Still not enough. So most of system, DBMS system have 95% to the 98, 99% hit ratio. If less than 95, something problem. So you need to do something others. Query may be the problem, or the database administrator has a problem, should be over 95%. It's very high. Because of that, DBMS is faster, even though it's very complicated, but still the faster to find the data. Then you may be curious, why not using the really physical memory for this? What do you think? Is it possible? Yes or no? Yes, maybe possible. Why not? Because this is the buffer, and it has the block, and this one is the data file, but it still has a block. So if we copy all of this to the memory, really fast, we don't have to the cache. Then problem? Saving.
Every time we commit, the value of
So you can commit and you can apply to the memory. But one of the main problem of two main problem. One,
power
Is it full? If it's full?
because it gives memory if it is lost.
so memory data is volatile. Without power, you may lose the data. So definitely you should keep the log or something change on the persistent hard disk drive. So if you keep all the data in the memory, this one also may be overhead. Okay? Another big reason, this one is small. Think about the even big data system, memory size 32 gig, pretty much that's the maximum. Then hard disk drive is 1 petabyte. You cannot keep all the data to the memory because of size and the cost. Much more expensive. So instead, you can bring some part of the data into the memory. Some part. So this is the kind of the rule. So it's called the 80-20 rules in information theory. So if you, so think about your laptop or computer. How many files do you have? So millions, say. Let's say the millions of them. How many files, among the million, how many files do you access last month? Maybe 10%? No, less than 10%. So think about your cell phone. How many photos do you have on your cell phone? Many. Probably 1,000 photos. How many of them you actually see your photo last year even? So somebody, so like the old people, look back the old photo like that, but mostly just the same, right? So nobody wants to delete. So in information theory, only 20% of the data are accessed. The other 80% is just for the archiving purpose. Same thing for any information. Digital information, analog information, library, go to the library. How many books are taken out? No, it's less than 1% even nowadays. So only such a 20% of data, actually it's less than 20% in real database system. Only less than 5%. Think about the banking system. Banking system, 90% of data is archiving purpose, transaction history. So we can keep the frequently accessed data. It's called the hot table. Hot table into the memory. It's a memory-based database system. Also nowadays, to speed up, it's called, for example, Memcache is a NoSQL database. So you can keep the database, part of database in the memory for the faster. Okay. So this is the so go back to here. So this one is, you can see the block by block. It's a block-based approach. So it's a kind of logical diagram. Basically, this block will be here, this block will be here, this block will be here within the table space or database. We can use a hash. So some details of a hash I skipped, but you should definitely know. You should know the general hash, the characteristic and the problem, because computer science, they use a lot of such a hash function and hash approach, and database also. I want to skip the RAID, but still the RAID is used. The idea of RAID is when hard disk drive was very expensive. So it was 1983 when I had my own personal computer. So 1983. Can you believe? At the time, my dad, gave me as a gift, the birthday gift, is an Apple computer. When Steve Jobs was the CEO of his first, before he left. Okay, actually he left Apple, then coming back. So before he left, it's the personal computer. It's even before the graphical user interface. It's the 16-bit the computer. Cost at that time is around 2,000. Really expensive. But I believe my dad worked for the bank. Work in the bank, so one of his customers actually started a business like that. He should buy the computer. He didn't know what is even the computer, but he purchased. But at the time, I enjoyed the personal computer. Then I learned the programming. Like anyone who ever used the basic program language, GW Basic, it's a basic, really basic program language. It's very simple. So using that program language, I actually awarded the first prize of the programming contest at the time. So it's a kind of the old company of the LG. So LG actually started the computer business at the time even. So I actually received 70–80% of the purchasing price as an award. So it was not that. But at the time, what was can you guess the size of the hard disk drive? 12? Close. It was 15 megabyte. Then cost is 800,000. It's really expensive. The hard disk drive. So I stored my program not hard disk drive to save the storage. Instead, it's a magnetic cassette tape. Do you know that? It's a cassette tape. It's a magnetic tape. We use the magnetic tape to listen the music. So going back to back. But the magnetic tape, as long as you can store, like think about the credit card. There's a magnetic, so you can keep the personal information. So it has the basic information in the magnetic. So because of that, such a magnetic, the credit card is not safe. If you have reader, magnetic reader, you can actually get all your data, right? It's very easy, and also copy. Because of the chip nowadays it's used. So magnetic, also you can store the 0 or 1, which means you can store the binary, the data, which means you can store the digital file. So if you turn on the cassette tape that stores the digital file, it's like the weird noisy sound. So you heard about that, such a noise sound. Another similar noise sound is from the internet through the telephone line. So at the time, it was not internet. Internet was the late 80 and the beginning of 90. So at first time when I logged in the Talat, and it's not SSH, the email was the 1994. But even we had the similar communication through the telephone. It's kind of the communication, the group. So you log in that group, and it's one server, and it's through the telephone line. So problem, huge deal, because you should connect the telephone all the way. So at that time, to save the storage, so think about what is the best way to save your data. Mirroring. You have exactly same copy of the data. Problem? Only 50% utilization because it's the mirror, right? So you cannot use over 50. So then it was very expensive. So is there any other way? So at the time, the RAID technology actually tried to keep both of the high utilization and the save the data. How to restore in case of the damage? Can I insert the data? So that is RAID technology. But you can just keep in mind only this one, RAID 0, 1, or RAID 1 or 0. So RAID 0 means it's the striping. Okay? So striping means, so if you have let's say this one, when you have the full disk drive, so you are going to divide the storage by the number of the disk. Then spread out. So D1, D2, D3, the A1, A2, A3, A4. This one is B disk, B1, B2, B3. It's a stripe. Okay? Benefit? You can do the parallel processing because data is striped. So that is the 0, RAID 0. And the 1 is a mirror. So you can exactly copy of this one. So based on that, a copy of that. So nowadays, most of the storage use such a mirror as well as stripe. If you are doing the stripe first, then the mirror 0, 1. Or plus, sometimes it is if you mirror, then the stripe is 1 plus 0. So when you read kind of like the RFP, the request for proposal, so you are going to visit your customer. So your customer asks, we need something backup, and so at that time the storage should be 0 plus 1. Then you should understand what is a 0. 0 means stripe, and 1 is mirror. The 1 first the mirror, then the stripe, like that. And the other RAID we don't use nowadays because hard disk drive is so cheap. And how much is the 1 terabyte hard disk drive?
About $50.
Yeah, I think less than the 60 or 50. What about the 1 terabyte size? Is it still already in the market? 1 terabyte SSD? Yeah, there is, but it's
$150.
yes, it's 200 something like that.
Yeah, it was a 7
Okay. So SSD, the price-wise, so the SSD is expensive, but it's cheap, so we don't have to worry about the other rate. Then, if we can use the storage, for the network. So in other words, we are going to design the network based on the storage. Idea is, if we have a really big storage, instead of a local hard disk drive, we connect. Through the network, we connect this one. So if you design the network, it's oriented by the storage. It's called the SAN, Storage Area Network. Idea is, so one of the biggest problem of using such the connected network is, unless this is the bus, so you need to use the internet or the cable, so it's slow. Okay, it's a latency. So, however, nowadays we have fiber optics, the fiber channel, which is much faster than, almost similar speed as a bus. So using such the fiber channel, so we can actually reduce such a network latency. Then we can have, for example, such as a centralized storage and design the network. Benefit, you can dynamically change the allocation. During daytime, we need more web server. And nighttime, we need more space for the data or the data warehousing, like that. So this idea, virtualization, can be used for the cloud computing also. So storage area network can be used, let's say. I'm going to skip the NAS. Okay, nice question. And so. Okay, then that's the end of the storage. Next one is the index. Any questions? I think that I can talk at least 8 hours only for the data file. There are a lot of things. It's a fun, and there are the fun project to do only for the data file. Then you can understand the operating system. You can understand something computer architecture, computer organization, even the programming. So there are a lot of things. So do not ignore the importance of such operating system and computer organization. So eventually you are going to fight with such a performance. But without understanding the computer itself, so you cannot be winner. Okay? Programming is a kind of tool, okay, to communicate with the computer. So if you have boyfriend, girlfriend, but speaking other languages, so you do better. Use the common or your friend, the language. So then that is the program language. Then to fight with the performance, that's the main problem. So then you need to, one thing is algorithm. Okay? One thing is the algorithm, another thing is fighting with the computer, the hardware data structure. So this is one of the results of such a fight. So database, well, somebody mentioned about what is the main reason of using DBMS system. Do I have to use? So what do you think? Why we are using database management system? Generalize the data. This is one of the ways to manage the data. Why do we need to manage? Why do we use computer? But long time ago, like the 1940, 1950, even we never thought about such a sharing. Right? Then why our ancestor need to develop such a machine, computer? Faster.
To make life easier.
So access. So we have data. It's a bigger and bigger and bigger. So first time we use and writing the calculate in mind, definitely it's not enough. So we developed something, mechanical calculator. So it's a Leibniz calculator and so on. And typewriter style, something mechanical machine. Then even that's not enough. It should be fast. So we are going to use electric device, so electric calculator eventually based on something data structure which is based on the vacuum tube, 0 or 1, then the machine is eventually computer. all of them are based on when we access the data. They should be fast. Not just access, calculate, process. It should be fast. So I believe the computer should be fast first. Security later. If you think about the security first, you cannot. Think about the recently IBM released the quantum chip. Okay, so what is the main difference? The traditional, the current, the chip and computer, and versus the quantum. Our data structure computer use 0 or 1. It's a binary. Quantum, which means its power is huge. We can only process two the different thing and the combination data structure, so it's limited. But this one, the quantum is. But my question is, if you think about the security first to develop the quantum computing, no, you cannot develop. What reliability? No. First, speed. Okay, speed. So that is the main reason. So DBMS is should be fast when you access the data. However, as you realize, there are many components, which means it's overhead, maybe slower. So without computer, without the DBMS, you can manage your data, even though on your laptop. You don't want to use this. If you install the Oracle database on your laptop will not be running. But why do we use this one? And because when we have the much bigger data, so computer file system doesn't work. So we need this. How can we speed up to access or to manage such a data? One thing we already discussed. Using this one, memory, cache, or not cache, reduce. Okay. Another thing I didn't introduce yet, but we are going to talk about the query optimization. This is another way to speed up the query to access the data. Third one is that's not enough. Even the expensive hardware not enough. We need to different data structure. Okay? Because data file is either ordered or even ordered log n is not good enough, fast enough for our requirement. So any other way? So that need I'm not sure. Indexing. Okay? Indexing. Structure indexing is a data file. It's not data file. Indexing is also file structure. But it's for index data. Data file is the data structure for data table. So what is the index then? Anyone who has the textbook right now? So let's say that this is a textbook. Most of textbook has index at the end. How do you use? When do you use the index? To look up the specific page using what? Keyword. That keyword is sorted alphabetical order, A, B, C, like that. And also there is a keyword like the database, the database with what? Page number, like the 111, like that. Then you can go to the 111, not one time. The textbook is sorted by the page number in order. So you can use internally, implicitly you are using binary search, right? Then we can quickly find the page that you want. At this time, this is called the index key entry. Database has exactly same data structure as the index on the textbook. So this is called the index key entry, like the record in a table. This index key entry has two parts. One is keyword key. Okay. Another one is page number, address, or pointer. So for example, I'd like to search Lee. Okay, where is the Lee? Lee is in the data file here. Let's say this is a table. And this one has the student table has number of block. So let's say the lead is block number 1. So this one has the block ID. If you know the block ID, you are able to find the location of this. Who is in charge of that? This controller. Convert this one to here. So if you find the lead index key entry, the number 1 block. So going to the number 1. So you don't have to linear, you don't have to binary search, you can directly go to here. So this is the very basic idea of how to use index. Then we need to manage all index key entry for the key, all key. So first question, what column, what attribute can be the candidate of key? What column? Primary key, definitely. Okay. So primary key will be used. So if you create a table with a primary key, automatically this index file will be created. DBMS automatically use the index for primary key. Another one, candidate key. Candidate key is the same as the primary key, but it's not selected because we need only one primary key. So if you have the candidate key, automatically create another index for the candidate key. So this one is the social security number, primary key, and UBID is the secondary key. Another the index for the UBID, like that. Also, if you want, you can create the index for the name attribute. You can create it, even though that is not unique. So if you need, so you can create. But that will be the later problem. It's a performance issue. I will introduce later. So go back to here. So your data index file has number of index key entry. Each entry has the key and the address or block ID and the location of the data block. Okay? So this is an index. Then question, another question. So you are developing the DBMS system, like the data file. So I'd like to create the index. First, how can you create the index on a DBMS system? Create it. It's like the table. Exactly same as the table. So you can use either files or row device. So for example, if you are using the file, it has what? Number of blocks will be allocated. Number of blocks. Each block has the key and address. Key and address. Okay? Then, depending on how to organize the key entry, there are different types of index. Eventually, we will see a lot of different index. Eventually, we will see B+3 index. Anyone who heard about the B+3? No? Yes? Yes. What is a B+3?
I don't remember that, but
Yeah.
it's
So let me change the question. What does the B stands for? Binary. So it's not binary. This is common mistake. The binary tree is based on left-hand side and right-hand side. Only two children. Two children node. Then the parent will be used to decide which one is over. So only two. Two. If you have think about you have 1 million customers. If you create the binary tree, what will be the level? Log 1 million based on 2. How many level? 2 to the power of 10 is 1,000, and 1,000 of 1,000 is a million, right? So 1,000 level. You should have the 1,000 level, which means it takes a really long time. So definitely we are not going to use the binary tree for the index. This one is called the balanced tree. So we will see what is a balanced tree. I think that some of you guys heard about the balanced tree. during the data structure class. What is the balance? If all the leaf node is the last terminal node, has the same level, okay? So it's not skewed. Like for example, this is a balanced tree, but this one is non-balanced. It's skewed. Which one will be better? Balanced or unbalanced? Balanced? Unbalanced? Balanced is definitely better for performance. Because unbalanced, you heard about in the binary tree. This one is a binary tree, right? Extremely skewed binary tree. What is the same as what?
It's the same as a
Linked list. So extreme case, the unbalanced, the skewed tree will be the same as the linked list. You cannot get the benefit of the tree if non-balanced. So that's the reason we really balanced is a B+. There is another reason. We will talk about that reason during the query processing also. So what we're gonna do right now is we try to see how to organize index key entry for the data file. Still it use the what? Block. So keep in mind, the file system is based on the blocking always. Okay?
Professor,
Yes.
can we call indexing as a metadata?
So what do you think? Metadata is the same as index. So metadata is for what? One of the example of the metadata is catalog database. Catalog actually keep what? Structure of your table. What is the primary key? What is the name of the attribute? And what is the data type? Such a metadata is in the catalog. Index is the storage for what? Index key entry. It's another data structure. Catalog may include what attributes are indexed. What is the key? Okay? And what is the level of index? We will see why the level is important in the index. Okay? Because it's IO also. So number of blocks. So metadata also include the metadata information about index. However, index itself is not the metadata. This is another data structure to keep index key entry. So idea of index, the way the table is, first we are going to search the index key entry. Using address, we can find the table. That is a very basic mechanism idea of how to use index. The problem is how to organize. What are the data structure for index file? On the other hand, if you are asked to develop the index on the DBMS system, as we discussed last time, but UBDB that I showed the last time, it's not actually the index, only table. But if you want to implement this one, you can do the same thing. First, create the file system or the table space, number of block, index block will be allocated. Then this block will be organized by the first primary index, cluster index, or secondary index, B3 index, B+3 index. Good news, nowadays 99.999, the index used in the relational database management system are based on B+3 index. But the other index can be used for your program. So if you are taking the operating system, I really like the topics in the operating system. You will develop the operating system after you graduation, most of you guys. However, most of the algorithm, many of the algorithms you learn from the operating system will be used for application, like the synchronization or the semaphore and the file system, and even in the algorithm. So index, we will see, even though these indexes will not be used for the commercial DBMS, but you intuitively And even though you never learned, never heard about such a name, but in your application program developing, you are using some of the technique. Okay, so we will see. So, unlike the table, the index, it's not called the record, but it's called the index key entry. It's not data entry, it's an index entry. It's a field value. Field value means that it's a key plus the pointer. Pointer can be address, pointer can be block ID, and the commercial DBMS has their own data structure, address format. For example, Oracle has the row ID. So it's their own ID format to find. It's the fastest way to access the data, row ID, for example, in Oracle. There are different types of the index. The first one is a dense index. Dense index means, so we have the table. So student ID is 1, 2, 3, 4, 5, 6, and James, and Lee, and Patel, and so on. So if you want to create the index, there are much more. So if you create the index for the name, this is the key. Okay? Or let's say, make the one realistic. 5, 6, 1, 2, 3, and 100. So it's an unordered file. We'd like to create the index for the ID. Then, index is like the 1, 2, 3, 4, 5, 6, and 100. And so let's say that this is one block number 1, block number 2. So 1 is in the number 1, and 2 is in the number 2, and 3 is in the number 2, and the 4 is in the, let's say 4 is number 3, and 5 is in the number 1, and 6 is in the number 1, 100 is in number 2. So point like this, like this, and this. So this is an index. So when you create the index structure, if you keep the all data entry, data record, so all the data will be indexed. That's called the dense index. Okay? If you index all in the data entry, that will be indexed. In other words, number of key entry, index key entry, is the same as number of data record. This is a dense index. However, if you have a less index key entry than the data entry, it's a non-dense index or sparse index. For example, I have the department, the ID, D number. So if you create the D number is 111, 222, like that. Only 3 departments. So you can create the index for the 1, 2, 3. Then 1 is the here. So number 1 and number 2, like that. You can have the multiple pages. So this one is only 3, but you have the 7 data entry. At the time, it's called the dense index. A non-dense index, sparse index. So there are 2 different types of index: dense index, non-dense index. Question: textbook is a dense index or non-dense index? Non-dense, because we cannot create the index for entire the word in a textbook. It will be huge, same size as the textbook, right? So dense index will be used for mostly key. If the index key entry is not a key, then it's a non-dense index. Okay? In general, sparse index, non-dense index is definitely the general. I'm going to explain this one. So the main reason why we are using index is fast. We need to prove, we need to evaluate how much fast, whether it's really fast or not, right? So it's an evaluation method. Idea of such an evaluation is, I mentioned several times, how can you? It's the number of blocks. We are going to count number of blocks. For example, 1, 2, it's a 2. And if you need 1, 2, 3, so which one is faster? 2 is faster. So we will evaluate such a using index is really fast or not the next class. So we are going to start with time. 10 more minutes, okay? Not this. So first, the single level index. The single level index means this index level is just 1. Okay? So 1 linear like the. So we have a number of blocks. The multi-level index means we have this one and point, which means index of index. Can you imagine what is the index of index? Think about the textbook index. If textbook index is really big, like 100 pages, we don't know where is the A, and where is the B start, where is the C start. So A is starting from the 400 page, and the B index starting from the 410 like that. If you have such an index, that's the index of index. At the time, this is called multi-level index. However, if you have only one level of index, it's a single level index. So first we'd like to see the single level index. So first, the single level index is if you, definitely as we mentioned, if you index make the key, primary key, that's called the primary index. Okay? If you are using the primary key, that is the order. First order, 1, 2, 3, 4, 5, 6. Order. Then if you create the index for this primary key, it's ordered. This is called the primary index. Somebody may be curious. Why do I need to create the index that is already ordered?
It will not be in the form of a table, stored in some address.
This one, how many blocks do you need? Log something. So we are going, not log something. So we have a number of block n. What is the time complexity? Log n. Which means the more data you have, the longer time. It takes longer time. So why not create the index for this? Each block starting. Each block starting. Like that. 1, 4, 10. If you create the index for this starting point, which is called the anchor, the key. Anchor value. For the anchor value, we create 1, 4, 10. So we can create the index like this one. 1, 2, 3. How long it takes? 1, 1, 2, 1, 2, 1, 2. Always 2. Right? However, if you are using the binary search, it's a log and listen to. The reason is that when you read the index block, so even though you need to access many of this, definitely you need to search the 10 using binary search within a block. But within a block, you need to copy this one to the also memory. In the memory side, you calculate the binary search. How long it takes? Log n. However, that log n is on the memory I/O. It's not the disk I/O. So we can ignore such an overhead. Right? So then we can find the location of each one. So that is a benefit of the using index, even though ordered file. So many students are confused. Why do we need the index of the ordered file? It's already ordered. But if you have a really big file for ordered file, it takes also long time. So we need such an index to reduce. So this is the example of the ordered file. So you can see this is a table. How many blocks? 1, 2, 3, 4, 5, 6, like that. Then this first block has the add Aaron and up to the mark Acosta, like that. They are sorted. So order the file, and this is the key. So for example, if you search Mark Arnold, Timothy, if you search the Timothy without index, how can you search? You need to binary. So log n based on 2. Within one block, you need to do the binary search again, but we can ignore such overhead because it's in the memory, so you don't have. It's just a short the amount of time comparing to the disk I/O. So we can access the data log n based on 2. However, if you create the index, so we don't have to index all these values. Instead, Aaron add is number 1. Adams John number 2. And Alexander add 3. In one block. We may have the number of blocks if you have a lot of the block. Okay. Then the point. For example, if you access the Atkins, so you can search the Timothy Atkins. It's not here. Instead, you can find the Mark Arnold, and the next one, the James Wang. It's in between. So which means the Timothy belongs to the Mark Arnold. So going to this. How many I/O? 1, 2. So 2 I/O is enough if you have the index. So this is called the primary index. So primary index is the index for ordered file. Primary key ordered file. We will see next class how much fast for the evaluation, the previous one, so using this. Then another question. Primary index is the dense index or sparse index? It's a sparse because we need only 1 per block. So Arnold add, John add Adam, add Alexander. So 1 per each the block. So it's a sparse index. It's a still single level. We have the 1 level of index. We will see this one, how much fast later. Okay, another single level index is a clustering index. Cluster, what's the meaning of a cluster?
Many blocks are joined together.
A lot?
Many blocks are joined together.
It's a group. It's a grouping. Right? Clustering in nowadays machine learning is it's a grouping, similar way. So grouping there are such a grouping the index. For example, in employee table, if you think about the company database, employee has the DNO, right? So if you sort the data, order your employee file by the what? DNO, not primary key. It's ordered by the DNO. What will it be? It will be like this. So the employee file is like that. It's a DNO, 111 and employee information, 222, 333, 44, like that. This one is the ordered file, but ordered by what? Non-key. It may be possible. So can we make the index? Yes, we can make the index like this. 1 to here. 2 start here. 3 start here. Okay. 4 start here. So it's not the 1 entry per block, instead 1 entry per value. Okay, DNO. So this is called the clustering index. Question, so clustering index is a dense index or a non-dense index? It's a non-dense because a lot of data entry, but it's only the number of them. Sometimes, so the two is different from the previous number. So if you want, you can separate the per block for per value, like that. So it's a 2 start. Even though you have the remainder, so we are going to start from the new block, like that. Okay? So this is another version of the cluster index. So we have the primary index for the order is a key. And the second is the clustering index. Clustering index is for the non-key order. Okay, non-key order. Third one is the secondary index, most popular one. Secondary index is for example, this is an employee. So this is it's already sorted by SSN, Social Security number, ordered by Social Security number, but I'd like to index for you the employee ID. Let's say this is employee ID, but it's not sorted. Also, sometimes non-ordered file. Non-ordered file, this is the key or the secondary key. So can I use this one for index? Yes, so we can create the order for the index, then the pointer to the data block address. Like that. 17 is go to here, and the 24 is go to here, and the 1 goes to here, like that. So this is called the secondary index. Secondary index is the most popular among single level index. Okay, it's a general case. Question, is it dense index or non-dense index? It's a dense index. Okay. For example, when you search number 4, how can you search number 4? First, find the block. How can you find the block that include the 4? Along the index block, you can search by binary search. Okay. Then this one, the within a block, so without any cost, find the address. So 4 is in the here. Then 4. So you can save a lot of the IO using index. So there are 3 different types of single level index: primary, cluster, and the secondary. Primary is for the index for key order, and the cluster is non-key order. And third one is even key or non-key, but if that is the not order, general case is a secondary index. We will see how to evaluate that. Sometimes, if we have, it's not the key, but it's like the non-order. It's unordered data file, but it's non-key, which means there are one department number. So, which means 1 is how many? 1, 2, 3. So 1, 2, 3. So this is not considered as an index. This is an array. So you can keep think about when you search the specific keyword on the textbook, like the database. How many pages? So 10 pages. So 10 or the 20 or 100, the 210. So it's a multiple location that shows the database. So how can? It's an array. You can use array. So when you have the multiple the block, you can use it's an array. So this is not index. Still we are saying this is a single level index because we have the single level. This can be part of the here if we are using array or list. So this is another example of a secondary index. This is a summary of a single level index. Then, last thing today, let's go back to here. So here, how many? Where is it? How many blocks? 1, 2, 3, 4, 5, 6. And how many index blocks? 1, 2, 3. But if you had 100 blocks, it will be bigger. So
Waiting outside.
rain?
No, people are waiting outside.
Waiting outside. Okay, so it takes a longer time. How can you address? We can create the index of index. So that is will be multi-level index. What if this one is still big? You can create another index. So index of index of index. Eventually, it's a tree structure. So that is the reason we need the something tree in the index. We will see the details of that in the next class. Thank you.